everyone, and thank you for tuning in. You're watching In the Studio. I'm your host, Lynn Weaver. The program is brought to you by Davis Media Access and is broadcast on Davis Community Television, that's Comcast Channel 15 and AT&T UVerse Menu 99. We're also online at dctv.davismedia.org. Today, we're going to talk about an exciting series of experiments that are taking place right next door to us, really, in the Yolo Bypass, or rather the floodplains of the Yolo Bypass, showing that baby salmon, when placed in the rice fields, in the flooded rice fields, grow at a fantastic rate, at a rate that has not been seen before. And my guest here to talk about it is Carson Jeffries. Thank you so much for being here. Carson is a fish ecologist, and he's also the field and laboratory director of the Center for Watershed Sciences at UC Davis, and he is one of the co-authors of a recent report showing some fantastic findings. The research is been regarded as very promising and excellent, and he's actually been, the research has been in the media recently, being picked up by some of the major press in the country, actually. So welcome so much, Carson, for being here with us and for taking a little time out of your schedule. I'm going to ask you, my first question is this. The 50,000 plus acres of the Yolo Bypass, of the floodplains, have been for a very long time used or managed for flood control and for flood control in agriculture, namely the cultivation of rice. So what gave you the idea, what gave you and your team the idea of introducing baby salmon into this habitat?
Well, it started in 1997 with Ted Summer, who works for the Department of Water Resources. And 97, 98 was a very wet year. And so they thought that they would try putting baby salmon both on the floodplain and in the river, and then comparing the growth between those two when the Yolo Bypass was actually flooded. And they found that the fish that were actually released into the floodplain grew a lot faster. And so that got the wheels turning about how floodplains work and how they could have historically worked for salmon. And so what we started doing was looking down on the Cosumnes River, which is another step down the valley, yes. But there's a natural floodplain there that floods every time the water comes up, it floods, unlike the bypass, which is only during flood events.
Yes.
And so we were able to look at it at a smaller scale and understand the processes that allow for good food for the salmon to grow. And so from what we learned between these two locations, we decided that thinking about what happens during the non-big flood years, but necessarily the small years,
yes.
when we could manage the floodplain and the rice fields for the juvenile salmon. And so with that background, 2 years ago, we started with just an experiment of just a rice field, very little experimental design as far as treatments, but we just put the baby salmon in. They were about 50 millimeters, so about 2.5 inches when we first put them in. And then we watched them grow over 4 to 6 weeks. And so this last year, we got a little more rigorous with our experimental design and tried to look at what actually are the processes and the habitats out there as far as the different rice treatments, as far as whether fallow fields or whether they were fields that had been plowed under or where there were fields that were left with the stubble still up. Looking at, are one of these habitats better for the salmon?
And did you come to a conclusion, or you're still studying that? We're
still studying it. We learned a lot this last year. We learned that all of the habitats, they grow really well. And we saw growth rates that you just none of us have seen before in fresh water. These are growth rates that you see in the ocean, where it's a very productive place. And we're seeing some of those same things happen on these shallow rice fields.
which is fantastic. And obviously baby salmon like rice then, or rice byproducts, it seems. And there must be another reason for introducing baby salmons in this habitat, maybe protecting them?
Yeah, that's the protection is a long-term picture, in that we think the best protection for the fish is having them big and fat by the time they're ready to go to the ocean.
Yeah. So they'll be more resilient and,
Yes.
and better equipped. Yes.
Yeah, there's a lot of evidence that shows that the bigger fish are when they leave the freshwater, the higher the likelihood of them coming back. And you can think of it as when fish are migrating from their spawning habitats up near the dams, that they have to make it all the way down the rivers, and then they're on their way to the ocean. And so if they're able to get fat during that journey, we think of it as it's a freeway, and they're able to stop by at a bed and breakfast on the floodplain, they're able to put on some pounds and then head out to the ocean. And so it's that combination of being big at the right time during their outward migration that really gets this process going. And that's where we think that there's a lot of potential for having fat fish going out. And it's those processes on the floodplain. And once the water, when the water's in a river channel that's leveed, it's very narrow and it's very deep. Mm-hmm. But when it goes out onto an expansive floodplain, it gets shallow. And when it gets shallow, then there's a lot of sunlight hitting the water, and you have a lot of plant growth in there, like algae, and then you have a lot of zooplankton, which is something you often think of in an ocean as being the food source. But those same food sources are happening on the bypass also and in the floodplains. And we get up to about 170,000 zooplankton per meter of water.
That's fantastic.
It's a food soup.
Yes, it's a food soup, and they can. It's all you can eat basically for the baby salmons. Would you say that salmons are an endangered species here in the Central Valley at the moment?
There are certain runs of salmon there. So California has 4 different runs of Chinook salmon. There's the winter run, the fall run, the late fall run, and the spring run. And the fall run is endangered, and then the other 3 are somewhere between doing okay as far as the numbers go, and then to being threatened. There's some spring run or have a lower population than others. But so all of those fish, though, all of those runs of salmon can utilize the bypasses and the floodways during their outmigration to the ocean.
But your experiment is only limited to a certain type of salmon, the Chinook salmon?
The Chinook fall run salmon.
The Chinook fall run salmon.
And the reason we were using those fish was that because this is an experiment, we have certain limitations on what we can actually do, and that we didn't know if this was going to be successful or whether there's going to be high predation or high mortality from various causes.
Yes.
And so we used hatchery fish from the Feather River hatchery, and then we used a small number of wild fall run fish so that we could compare the difference between the two to see if we're using hatchery fish, is there a problem, and it doesn't necessarily represent what the wild fish would do. And the thing that we found is that it was so productive that there's no competition for resources when the resources are very abundant. And so we didn't see any difference between the hatchery fish and the wild fish. So for this experiment and future experiments, we're able to, as long as there's not a behavioral component per se, that we're able to use the hatchery fish as a proxy for what we could do down the road for future wild fish populations.
And what do you mean by behavioral problem? The salmon's fighting?
No, there's not a lot of salmon fighting. The behavioral component that is different is that when fish grow up in a hatchery, they grow up in a concrete ditch. And so there's not a lot of, and their food comes from the sky twice a day. It just falls down from the sky and rains through the water. Where wild fish have to compete for their resources in the wild. They have to avoid predators. They have to find their food.
I see.
And so there's a lot of work that's been done that shows when hatchery fish go out into the wild, is they're sometimes ill-prepared for those habitats when they get there.
That's fascinating. Well, in my introduction, I briefly alluded to the fact that the media has been very interested in the publication of your report and the results. Can you tell us what the key results that are in the report for us?
Yeah, the key results are that when fish are on the floodplain, is they grow really well. We had growth rates of over 1.5 millimeters a day, which doesn't sound like a lot, but when you're thinking about a fish that's only 45 millimeters when it starts, that growing 1.5 millimeters a day is a really phenomenal growth rate.
It's phenomenal, yes.
And so that's been the big thing, is that and we're doing this in a place that's being used for multiple other purposes.
Yes.
And that the Yolo bypass is its primary purpose is a flood control structure to protect Sacramento.
Yes.
And its second current, priority is farming.
Yes.
And then during the winter, then they flood it up for waterfowl. And then in the late winter, early spring, we're finding that can we fill that other void with a fish? We call it the 4 Fs. There's flooding, farming, feathers, and fins.
It's fantastic. It sounds extremely efficient way for agriculture and fish farming and protecting the environment against flooding, which is fantastic. So who gave you the idea of doing that? I mean, I mentioned it briefly before, but I want more details, the juicy details.
The juicy details is that there's a big group of us who are doing this. We have one of, I think, the most unique teams of people, and fortunately, everybody else is a really smart group of people, and we sit around about once a month and kick around ideas. And we have the agencies, we have the Department of Water Resources and NOAA Fisheries, we have the university, and then we have some nonprofits like California Trout,
yes,
and then the farmers.
Oh, yes.
And all of those groups get together because all of us have limitations for what we can do and what we can't do. Mm-hmm. But together we have a lot of ability to solve really interesting problems. And so we sit around and think about, what if we threw, we know that it works during the floods, but could we do it during those non-big flood years and do it under a managed condition? Could we take those natural processes and essentially turn knobs mm-hmm. in a controlled environment and get the same results?
Well, that's very clever, extremely clever. Can you describe a little more in detail how you set up the experiment and the timeline for planting the rice, introducing the salmon, and you mentioned that you do this for the fall, correct?
We do this in the late winter, early spring is when the salmon actually go in the fields.
Okay.
But there's everything that happens the rest of the year that essentially preps them for it.
Okay.
So
such as?
We'll start with the planting of rice.
Please do.
That happens
yes.
in May and June.
Yes.
So they plant the fields with rice. It grows throughout the summer. In October, they harvest the rice. And then once the harvest is done, then they flood it up again for the waterfowl that come in because this is on the Pacific Flyway. And so
yes.
about 25% of the birds in North America use these habitats along the Pacific Flyway when
yes.
it's flooded. And then they drain it. And then in January, we flood it up again. And then we put the salmon in the fields at that
yes.
time. And then our goal is to make sure we can drain it and have the fish gone and swimming out to the ocean in time for the next planting.
That's fantastic.
So the idea is that there's 4 crops.
Well, we have a video that I want to show, which shows some of your team in the Yolo bypass doing the actual work. And the visuals are very nice, so if we can call for this video, feel free to comment as it comes on the display.
Right now what we're doing is building an antenna that will track fish that have a microchip in them, which is the same kind of microchip you would use for your dog or cat.
The microchips are being inserted into 53,000 tiny Chinook salmon. From there, the fish are released into a new temporary home in the Yolo bypass.
We're doing this so that we can track their movement between different agricultural habitat types.
It's all part of a collaborative effort among UC Davis researchers, local farmers, nonprofits, and government agencies to see if rice fields in the summer might make for good fish habitat come winter.
This project's really neat because we are finally getting back to basics. That we realize salmon need floodplains.
After decades of building new levees and dams, less than 5% of Central Valley floodplains, nature's nursery for salmon, remain. This floodplain is used to grow rice only part of the year, making this project a great fit for farmers as well.
The bypass is probably the toughest area to farm because of the flooding, because of the late flooding, with everything that brings with it, the uncertainty, the weeds, the erosion, and everything else. By having more uses out here, it actually underwrites a lot of the farming and a lot of the infrastructure.
Scientists expect these fish to double their weight each week during their 6 to 8 week stay. That means they'll be more fit for their tough journey out to sea and more likely to return home as adults to spawn the next generation of salmon.
We say that that's a win for farms for flood control for fins and for feathers, because you're providing good habitat to both fish and birds on lands that really provide high quality agriculture and some of the most important flood benefits in the state.
Along the Yolo Bypass, Kristen Samos for UC Davis.
It's a very interesting visual of what you do, and there are many other videos, by the way, online, but mostly on the website for the Center for Watershed Sciences, and there you can also see Carson Jeffries' biography and his research in more detail. Now let's talk about a little bit about the survival rate of these baby salmon, and I was intrigued by a report, or I read that the survival rates were better in 2012
Yes.
rather than 2013, and do you know why?
We have a pretty good idea why we saw different. We had lower survival rates this last year than we were hoping to have.
Yes.
We had great growth rates, but low survival rates, which seems a little bit counterintuitive. But we started
Well,
looking.
they're more attractive, aren't they?
They're certainly bigger, and they're more
Bigger and
they're-
more attractive to predators.
to birds.
Birds.
And what we
Yes.
had happen is last year was one of the driest springs and winters that we've had in the Central Valley.
Yes.
And we had pretty much the only water that was out on the Yolo Bypass. Where during a normal winter spring is there would be water all over the bypass.
I see. So
But we-
there's a correlation between this drought, because all the birds congregate
Exactly.
on the same plane.
And
Oh.
so when there's only one spot to eat, all the birds go to that one spot. And so what happened is we started going out towards the end of the experiment as the rest of the fields throughout the bypass were drying up. And we started seeing a lot of predators such as herons and egrets and cormorants. And over the last 2 weeks of our study, if this were a management project, we would have released them early, but it was an experiment because
Yes.
we wanted to run this the whole course. So we got our data.
Yes.
And so we didn't release them because we wanted the end numbers. And because of that, we had higher mortality than we had hoped for. But we learned a good lesson.
Tell me what it is.
If it's going to be a hot, dry year,
Yes.
the fish have to go earlier.
I see.
In wetter years, you might be able, if it's wet enough that they're not going to be able to farm anyway, then you might as well keep some fish out there. But during those dry years, when there's a reason why they start farming early is because it's dry and they can start working the soil.
Yes.
And it's just not a good idea to have fish out there at those times. And so really it's a sliding scale depending on what type of water year we have, which will provide, one, the best benefit for the salmon and also the benefit for the rest of the community that utilizes that.
And of course, you being an ecologist, you understand this very well, and how the balance has to be just so for everything to come into place. But isn't there a risk in releasing the salmons earlier that they won't be prepared for life in the sea?
Well, historically, once the water would start to get low in a drought anyway, that they would already be on their way out.
So it's the natural process.
Yeah, there's,
Yes.
on dry years they go earlier, on wet years they either ride the floods or go later. And so there's a big, window that fish move out in. And so,
Yes.
we're still keeping them within that greater window that they would naturally move out.
Yes.
And we're just running it on a little more confined schedule. Because in a natural system, they would follow as the water comes up onto the floodplain and then recedes down. They would follow that natural hydrograph. But because this is a managed system, it's a little bit different because we're trying to mimic natural processes,
That's right.
which were never as good as they are the natural processes, but we're doing the best we can within the framework that we have, and then understanding that some years are going to be different than others.
Yes.
And so having hard dates on there is a real tough thing for us to handle. And we learned a lot about that last year, which was good.
It was good. How many times you put on your wellies or your boots and you go out to the Yolo Pass?
We go out every day during the experiment. So for 6 weeks, we have people out there every day, whether they're looking at the water, we're sampling the bugs, the water, the fish, And then we have various experiments going on within this also. And so there's that's the good thing about having a large group of people is that we always have somebody who's, signed up to go out on your weekends,
Yes.
at night. We do lots of things to make sure that we can get as much information, because doing an experiment over 6 weeks, it sounds like a long time, but it's a very short period.
It's very intense, yes. Are you worried about pollution in the floodplains, or is there?
We have none of the samples that we have looked at has anything specific. There's concerns of mercury,
Yes.
but we haven't looked at any of that. There's
Not
some
yet.
there's some other studies that are going on that are looking at it, that are on other places on the bypass.
Yes.
But those are always concerns, and it's really balancing the benefit and the risk.
Yes.
And where does that line meet, and how do they? We don't know that yet.
You
And
don't know, and of course you need to segregate your research studies so that you have some valid results. In
Exactly.
a way, has your research been duplicated somewhere else that you know of?
Not the rice field side of it.
Not the rice field.
Because it's really only a year or two, and
That's right.
we're still we know that the proof of concept is there, but the actual management scale of it, the scaling up for a larger
Yeah.
program is not quite there. We're asking more questions this next year about the predation side of
Yes.
it, with the birds and the avian predation.
That's right.
How can we configure the fields to see if there's changes that the farmers could do that would actually make it so where there's less avian predation for the fish on the field. So we still are answering some questions. We're answering questions where last year we kept them on the fields and didn't let them leave until the end.
Yes.
And this year we're going to let them go on their own volition.
Yes.
So that-
provided it is a dry season, right?
Oh, we're going to let them go throughout.
In any case.
Yeah, so that if there's a point when they're ready to go,
Yes.
then it would actually be, from a management perspective, something that would be easier, because you don't have to have somebody maintaining the thing that's keeping them in at the outfall of the ponds, because there's always water running through the ponds.
Yes.
And if there's a point when they're ready to go physiologically, if they're big enough and fat enough and ready to go, then we're going to let them go, and we're not going to hold them in. So that's the next kind of management questions that we're getting at with this next year.
It sounds wonderful. Would you say that this research could be of great value in developing countries, assuming that they have salmon?
They don't necessarily have salmon, but this is actually something that's been used in lots of places for a long time. Southeast Asia and India, they oftentimes flood their rice fields, and then they have fish that come out with it. And then when they dry the fields, then they actually harvest the fish that go in with that, or as the water's ending.
So you're returning to the basics in a way,
Yes.
and it's long overdue, because we've done so much with technology and everything, and then something as simple as that, and correct me if I'm wrong, but relatively low cost is welcome. Wouldn't you say that?
Yeah,
Yeah.
to make these type of things work is they can't cost a lot of money.
Right.
And whether it be from the farmers or for who's ever paying for it.
Yes.
And that land is valuable, particularly in California, and so is water. We
Yes.
live in
Yes, as we know.
the land we
Yes.
live in is very
And-
complicated.
Yes,
And
but it's also a wonderful opportunity to experiment, because
Exactly.
the Delta is pretty unique.
Yeah.
But let me ask a couple, since we are community television and we do this to inform and educate our community, but also to involve them, what can the community, assuming that it's nothing terribly scientific, what can our community help with this project, either directly or indirectly?
I think indirectly is probably the biggest thing for this particular project, is that understanding that lots of people in Davis and Sacramento drive across the causeway
All the time,
all the
every
time.
day.
And you see the changes on what a diverse place it is.
Yes.
Most of the time when we see it, it's agricultural land. And when we, probably the only other time you notice anything out there is when there's thousands of birds or bats flying up above,
Yes.
or whether it's flooding. And that understanding that we can take these lands that are being used for many purposes and add, back some of the salmon, for instance. Oftentimes I'm pretty confident that when most people drive across the bypass, they don't think about salmon.
No.
And I think that, putting that into people's mind frame or
Yes.
mindset is a very good thing. I know that, in the Pacific Northwest, salmon are a part of the culture.
Yes.
And it used to be in California historically. And that, thinking about salmon and understanding that the lands that we live on and around are part of a very complex ecosystem, and that we're trying to integrate some of these ecosystem services is very important.
It's very important, and it gives renewed respect for what the land is, and not only the beauty, but it feeds us, and it helps us and keeps us dry from floods.
Exactly.
But that's Carson, any future projects that you have?
I think we're going to continue looking at floodplains. Floodplains are a real important part of California. The whole Central Valley used to be a floodplain. It was a marsh.
I know.
There was the book,
yes.
Battling the Inland Sea.
Yeah.
There's a reason why this was called the Inland Sea, and that so even if it's on a managed level or small natural floodplains, that floodplains are an important part of the river and the Central Valley, and that thinking about how this can function within the framework that we have currently, and reconciling the fact that humans are going to be here, and how can we work within that framework to benefit the ecosystem is one of the things that we are going to look at going forward. And we're continuing to look at that not only on the bypass, but in other places throughout the valley.
In other places. And of course, with the help and the support of the farmers, the local farmers who are doing this for it's their business for them as well, so they have a vested interest in collaborating with the researcher and the scientists. Well, I'm afraid we're out of time, and so we have to leave it there. But thank you so much, Carson, for coming here.
Thank you.
I'm looking forward to hearing more once you have new results, and perhaps we'll have you back to talk about that.
Sounds like a plan.
And good luck with all your media exposure. I'm sure sometimes is a little inhibiting, but well deserved.
Thank you.
So, and thank you all of you watching from home. If you'd like to see this program again, you can go to our website, dctv.davismedia.org, and while you're there, you may want to watch some of our other interesting programs. So you've been watching In the Studio. I'm Lynn Weaver. See you next time.